It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always, my co-host Andy Grabner is with me. Hi, Andy. How are you doing?
Not too bad, actually. Now talking into the right direction of the microphone, I believe people can actually hear me because that was my problem in the beginning.
Yes, you're an audio. You're a performance genius, but not quite an audio maestro.
Yeah, but
getting
there.
You'll get there, Andy.
Yeah,
You'll get there.
I think so
You'll
too.
get there. Your voice, I got to just say, I love when I'm editing the shows. I love hearing you on the microphone instead of the headset. I'm sure the listeners do as well. So that's awesome.
Yeah, I got the feedback from other listeners too that the audio quality definitely increased. They also said the quality of the content didn't get better, but at least the audio quality increased, right?
Well, I think today's content will be very, very good because I think it's a very it's sort of a new topic, one we haven't really covered too much yet, and I think it could be confusing when you're first getting into it, depending on your level. Why don't you go ahead and introduce the topic and then introduce our guest, Mr. Grabner?
Yeah, sure. I mean, first of all, I want to say thanks to the folks at Dev Experience in Romania who actually introduced or allowed me to get introduced to Matt Turner, our guest of today. I met him at Dev Experience in Iași, a city in the northeast of Romania, where he gave a talk on the life of a packet through Istio. Now, that was very interesting for me because I learned a hell of a lot about network basics and how routing works and how Istio works. And that's when I reached out to Matt after the talk and said, hey, there's so much you know. And then he told me a little bit about his background. But instead of me repeating all the stuff that he said, I just want to hand it over to Matt. And maybe Matt, I know you should be with us right now online. And if you could, introduce yourself, your background, or what you've been doing, what you're doing right now. And then we want to learn more about service meshes, Istio, what else is out there, what people have to know in case they just get started on that topic.
Sure. Yeah, I'm here. Pleasure to be with you. Can you hear me? Am I talking towards the right microphone?
Yeah, it sounds good.
I passed the first test, piece of expertise. As I say, it's a pleasure to be here. Thank you very much for having me. I met Andy in Iași, Romania at Dev Experience, which was a great little conference, actually. Lots of really, really good advanced talks. I actually sat in every session that I, apart from the one I was presenting, and it was, really informative. So that was a great place to be. I'm Matt Turner from London in the UK. I'm a software engineer and computer scientist by training. And I guess for the past sort of 5 years, I've always had an interest in systems. I've always been building servers and Raspberry Pis and stuff at home. That's, I guess, the hobby part of my experience with computers. And I guess about 5 years ago, this DevOps thing started to happen and the infrastructure and the platforms became more important. And I was like, oh, I know that stuff. I thought this was just, a nerdy hobby, but this is really relevant now. So I guess I kind of got into that. I did a bit of, old school orchestration and management of VMs, the early lift and shift to early cloud, and that was OpenStack. And I've kind of followed the technology since then. So with Docker, with Kubernetes, and now with Istio and the other service meshes, which are kind of at the forefront of the cloud native landscape.
Cool. So, the service mesh, you just brought it up, and I think Brian actually, asked about this when we kind of prepared for that talk. Can you, give a quick one-on-one on service meshes and what problems we try to solve with it and how they work? Because I'm pretty sure, part of the audience obviously is aware of it, but just to level set everyone.
Yeah. So I guess to turn to a service mesh by way of a problem, if you think originally that we would have a big monolith, right? A big hunk of software that was probably written in C++ or Java or PHP. And that could be millions of lines of code. And that thing, that thing worked. We became quite good at writing those. We have dependency injection systems. We have, modularization, modular loading. And we became good at avoiding common anti-patterns, things like inversion of control. But ultimately, all of your code was hosted in one big blob, and it ran in one big process. So although you might have, a domain-driven design aggregate that was almost a sort of separate little piece of software to another part of the system, to a different namespace, where one wanted to call another, that would just be a function call, right? And any computer science 101 course will tell you, how arguments are actually passed sort of in registers on the CPU. So that was really simple and really fast, and that never failed. But then our systems got bigger and bigger. We needed more and more scale. And we broke that monolith up right into microservices. And obviously there's a bunch of other reasons for that. I guess I don't need to explain microservices. You can then release every service independently and whatever else. But there was a tendency to take this monolith and to split it into all these pieces and run each one in a separate container without really fundamentally changing the way that the system worked and the way that communications across these boundaries happened. So what you ended up with was, to give it a glib name, a distributed monolith. So you had all the same code as before, with all the same failure cases that you could have before, but now things that were previously a function call just between one class and another that could never fail, now could, because they're going across a network, and Kubernetes might have these two containers on different sides of the planet. So we needed to cope with that. We needed to add a bunch of resiliency to cope with this distributed system that we've now built. So the early attempts at this were libraries like Hystrix and Finnegal from the Netflix open source stack that people have probably heard of. And they gave your applications facilities on a sort of an RPC call, like backoffs, like retries, like circuit breakers, timeouts with defaults, that kind of thing. So all of these functions mitigated the fact that a network call now might be unreliable. But they were in process. You downloaded a library, you added it to your Maven config, and that was a big hunk of code in each and every copy of the microservice. And you needed to upgrade it, and you need to do a rolling upgrade, a rolling update of your 1,000 lines of microservice business logic every time this 100,000 lines of Hystrix changed. So what a service mesh does is it takes that functionality, it takes those concepts, and it moves them completely away from your application. It moves them out of the process altogether. So you can imagine if you need these kind of retries and timeouts, then you might use a sort of advanced HTTP client on the one side, and you may use you'd set up an HTTP reverse proxy on the other side, like an Nginx. You think your API gateway has a lot of these functions for you. So what a service mesh does is it takes an HTTP proxy and puts one next to every microservice. So in Kubernetes speak, if you're on Kubernetes and each service is in a pod, then we add this HTTP proxy as a sidecar, as another container in that pod. And it intercepts all traffic on the way in and the way out. And on the way in, it'll enforce rate limiting and sort of parallelism constraints and stuff. And on the way out, it'll do circuit breakers and retries and timeouts and everything else. So you get all of these network functions kind of for free, as it was, ambiently from your infrastructure. You certainly don't have to write the code to do them, and you don't even have to sort of vendor in the code to do them.
Wow, that's pretty impressive. In a couple of minutes, I think I finally understand the whole history and actually what problems we are really solving with this. And I think it's, for me, the big aha moment, and I just want to be honest here because I'm, definitely not the expert on this, but for me, the big aha moment from when you explained in the beginning, we had Hystrix and Finnegal, and now we have, the services like Istio, is that the first approach was a library that you bake into your code. And then you made an interesting comment where you said if the library changed, you had to redistribute and recompile and redeploy all of your services. And obviously you're taking that burden away by extracting the functionality of a service mesh into its own entity. And therefore you're completely independent. You don't have to touch your code. The only thing you do is really you're injecting a sidecar into the pods. And I think that's obviously, that makes much more sense.
One question I wanted to get for clarification too, because I know you're about to run away with this. One of the parts that was explained to me, and I want to make sure I understand it correctly now that I have both of you on the I was going to say on the phone, boy.
It's a metaphor.
Both of you. Yeah, exactly. It's like, we're going to tape that. Now that I have both of you here, one of the other benefits that I heard about this, and I just want to make sure I understand it correctly, is that it's also like your services will register themselves with the service mesh so that you don't have to also tell your service is where all the other services are. They just call into the service mesh. The service mesh knows the map of that and then routes it to where it's supposed to go. Is that another one of the big benefits of something like a service mesh, or did I understand that incorrectly last time?
Yeah, that's another big advantage. I mean, there's a few, coming from the history and the problem, there's a few things I missed out, and we can talk about the rest, I guess, in due course. But that service discovery is definitely a big piece. The practicalities of, say, an Istio and Kubernetes system are not quite that the service registers with the service mesh, but it effectively works like that. The service mesh gains knowledge of all the services. And as you say, you can a service then making a call can use a sort of a short name and a non-qualified domain name, or anything that's DNS compatible, but doesn't have to be a sort of globally valid FQDN that you would go to the top level name servers and recurse to look up. You sort of throw this request into the ether with the correct host header, and the service mesh will get it to the right place. It also understands, because it understands logical service names like that, and it understands that they're comprised possibly of several instances of the workload. So in Kubernetes speak, you'd have one service with a capital S made of, a couple of deployments, lots and lots of pods. The service mesh can understand physically where they are, which region, which availability zone, which host they're on, and it can start to do things like route to the closest one for performance reasons.
Hey, talking about performance, because I think this is a question that I heard people ask before when people presented about Istio and the service meshes in general. So if you're injecting, let's say, an Nginx or a proxy into every pod, isn't that itself a huge overhead? Isn't that itself like completely, very much complicating my architecture, even though I don't have to take care of it? But potentially with every microservice, I get another service that sits in front of it.
You do. I would hope that it doesn't complicate the architecture too much. I mean, you're right. All of this code and infrastructure is being added. And I guess that, a big thing I missed out in the introduction is that if you want to be pedantic, a service mesh is a mesh of services, right? It's all of these services talking to each other with this proxy that gives extra features. In order to be able to configure those proxies, in order for them to be able to do the service discovery that we just talked about, in order for them to know what characteristics to apply, they need a control plane. So they need one or more other services that sort of accept high-level configuration documents, and then pass that out to the little sidecars. So the architecture, if you look at every detail, does get more complicated. But as I say, you've dropped Hystrix for all your Java apps. You've dropped whatever the Python, all the advanced configuration you're doing to Python requests to try to do the same thing. But it's never quite a parity because they're different, libraries for different languages. So yes, it is there. But the architecture that the user sees, it should be completely transparent, is my point. Yep. The injection is transparent. The application needs no configuration to know that the service mesh is there. On the performance question, yes, there is an implication. So there are a bunch of service meshes on the market. One of the early ones was called Linkerd 1. So Linkerd version 1, it was basically a middle proxy. So there wasn't actually a proxy per service. There was one per Kubernetes host, and they all shared the same one. That was essentially the Finnegal library wrapped in a little bit more code. So it was a kind of a single bottleneck. It was on the JVM. It was actually written in Scala, so it was kind of worst case JVM performance. So it had a lot of features, but it wasn't fast. The newer service meshes, do address that. Istio doesn't use Nginx as a proxy. Actually, it uses a newer piece of software called Envoy that came from Lyft, the ride-sharing company. So that's written in C++, very deliberately to be a high-performance piece of software. It does its own thread scheduling. It's got its own RCU subsystem. It's obviously a non-garbage collected language. Matt Klein, the main author, has written a bunch of really interesting blogs on the performance tuning and the trade-offs they've made actually between throughput, because you can always just auto-scale more pods to get more throughput. They've actually traded throughput down to get better latency and to get tighter bounds on the latency. So performance is definitely at the forefront of people's minds, and a lot of thought's gone into it. Linkerd is now also on version 2, and their proxy is written in Rust, which again is very close to the metal and the garbage collection. Hopefully lots of performance benefits. But it can't be avoided. We did some empirical measurements sort of 9 months ago. And take this with a pinch of salt because there's 1,000 variables in an experiment like this, but saw about 2 milliseconds per service being added. So 1 millisecond for an Istio system, 1 millisecond roughly to traverse Envoy, the proxy itself, and actually 1 millisecond jumping into the kernel and out again a few times to jump through all the IP tables rules that do the interception, because that interception is transparent. Now, you can mitigate that by telling your application about the sidecar, having it send traffic directly there. Then you don't have as many context switches into sort of IP tables and back. But yeah, there will always be a performance hit. If you're trying to do high frequency trading, maybe it's not acceptable for you. But for most other applications, I'd hope it's just a blip in human time.
Yeah, I mean, there's always the idea of you can't get something for nothing, right? And it's always the trade-off. One question about the performance, the overhead thing, though. I don't know if you saw this. I came across this actually not very long ago because it came out in April. It was an article by this guy, Michael Kipper, where he benchmarked Istio and Linkerd CPU, and he found, not on response time, but I think Envoy was about 50% higher in CPU utilization than Linkerd. I don't know if you saw that or not, but it's just kind of interesting. But again, that's not necessarily impacting your application. That's more the service mesh usage. But yeah, there's always going to be trade-offs, right? And I think that's the thing. And you have to look at what those trade-offs are for what you're getting. If you're going to go back to managing all those communications manually, now you're paying for all these people to be able to know it, track it, and be able to keep that configuration up and running, and maybe even have software failures because it's not maintained, versus suffering 1 or 2 milliseconds extra on a transaction, which is really, as you said, a blip. So
yeah, exactly. And what is the cost of of a code path traversing a thread on your CPU traversing all the way through Hystrix, which you can now remove? I think the answer is admit to yourself that you're never going to get a free lunch. Work out what your actual requirements are and just test it. Yeah, I've been following Michael's stuff. I'm a big fan. He did that initial work, and then he did something more recently, actually, at higher scale, a much higher load, and actually it tipped. Like, I actually thought he found that Envoy was quicker in the first set of experiments, but then under a lot of load, it was Linkerd or something. I can't remember, but he's found some very interesting stuff. He's very methodical about his sort of experimental conditions. If they exactly match your environment, then that's great. If not, they're just an indication. Spin up your own load test, work it out, and then exactly as you say, go and look at what your business value is from this. Go and look at what the opportunity cost is of not doing this. Look at how much it costs the people. All of these other questions that should factor into a big tech decision like this.
Yeah, and you are right. He did come up with the follow-up on May 8th, so definitely.
Hey, so quick question here. You mentioned Envoy. So, and obviously, if you Google or Bing or whatever search engine you prefer, if you look for, let's say, Istio architecture, there's a lot of great overview pictures. And I know Matt we'll add these to the links for the podcast proceedings. You have a lot of lectures out there and articles that you did and presentations on Istio for beginners to advanced people. But if you look at the architecture, then you see Envoy being obviously injected into the pods as a proxy to intercept all the traffic. Now, you mentioned earlier there's a control plane kind of on top of it. And could you explain a little bit more about what makes up the control plane so people are a little bit more aware of when they hear things like pilot, mixer, and authenticator? Yeah,
so I guess what I'll talk about is Istio in the setting of running in a Kubernetes cluster, because that's almost always what's written about, almost always how it's used. Istio can run outside of Kubernetes, but you have to do a lot of stuff yourself. It gets quite complicated. In Kubernetes, as I'll talk about, some parts of Kubernetes are leveraged to sort of help control things as well. But so basically, you've got the Envoy proxy as a sidecar to every service, which means that every Kubernetes pod has another container running Envoy. Envoy is quite a modern piece of software, so it takes configuration over an API. Not off a hot reloading file on disk. So Envoy is a nice little thing that's sitting there waiting to be configured, but something needs to tell it what to do. And you don't want that to be you, because it would be super complicated. So there's this control plane with which you interact, and you give it higher level configuration, and it tells all the envoys what to do. So there are sort of 3 or 4 components, 5, 6, depends how you want to look at it. But the 3 major ones, the first one is this thing called Pilot. Pilot is basically the configuration system, the sort of configuration compiler, if you like. So if I want Istio to implement a fault injection, 10% 500s, right, for chaos, then I write a YAML file, looks a lot like a Kubernetes YAML file. I write an Istio YAML file to an Istio schema that tells Istio that I want a fault injection and the return code should be 500 and it should be 10% at the time or whatever. I submit that to Istio. Pilot then effectively compiles that, transpiles that into the configuration format that Envoy wants, which is a different document form, and it sends that down to every Envoy to tell it what to do. Where the integration with something like Kubernetes comes in is what we were talking about earlier, say service discovery. The sidecars don't actually sort of call in and register with the mesh. What actually happens is Pilot goes and talks to Kubernetes. It says, well, I'm running in a Kubernetes cluster and I want to know about all the different pods, all the different workloads. Well, all I need to really do is effectively kubectl get pods against the sort of local Kubernetes API server. So it does that. So it takes in service discovery information from a bunch of places, including Kubernetes, and it takes in all the extra configuration documents that you give it to give it any kind of non-default settings, and it compiles them and it pushes them out to all the envoys. The next component is something called Mixer. So where Pilot is for sort of upfront configuration, the kind of thing that you would write into a config file if you were configuring it manually, Mixer is like online decision making. So say I've got a rate limit, say I've got 3 copies of the pod for service A, and I want 1,000 QPS rate limit across all of them because maybe they all call off to the same database behind the scenes. So I can scale to as many as I want, but that doesn't help the bottleneck in my system, which is this one database. So I can have 1 or 3 or 5,000 copies of the service A pod, and they only really can take 1,000 QPS between them because each time I touch one, it calls the database, say. That kind of rate limit can't be pre-programmed into a configuration file. Each Envoy could get configuration saying, well, your local rate limit is 1,000. But if you want that kind of global coordination, then you need effectively a global counter, right? A global histogram bucket. So that's the kind of thing that Mixer provides. So there's a very tight communication loop between the Envoys and Mixer. So for something like a rate limit or for whitelist, blacklist policy, every time there's a request, the Envoy sidecar will call to Mixer and say, hey, is this okay? And Mixer will check its rate limit bucket or its up-to-date policy list or something, and it'll give a reply. The other, I guess, fairly big feature that I missed out in the introduction to Istio is the observatory, the telemetry that you get for free. So because all of these proxies are on the wire and they're handling, actually passing through every network transaction, they can produce a log at each one, and they can produce metrics about all of the different characteristics and all of the rates. They can produce trace bands if trace headers are being propagated. Again, all of that stuff that you'd have to import like a Zipkin or a Jaeger client library to do, and then wire up your web frameworks logging and all of that stuff. If you've got this proxy on this universal proxy on the wire next to everything, Istio can totally do that for free. And the way that works is through Mixer. So Envoy tells Mixer sort of the raw, it basically sends it the headers of the transaction that's gone through. And then Mixer will send that. Mixer is configurable. So you can say, all right, I've got a Prometheus server over there and an older Graphite server over there. Both of those want metrics. And my logging server is Elasticstash over there and so forth. So that's what Mixer does. It's a central aggregation point for sort of real-time policy and for observability. The next major component is a thing called Citadel. So that deals with the security. The Istio sidecars can give you mutual TLS between all your pods. So if you think about a normal microservices setup, you tend to either not do TLS, you just do an HTTP, plain HTTP call between pods. And you sort of make an argument about defense in depth, saying, well, I'm in a Kubernetes overlay network in a VPC, it's fine. But MTLS certainly doesn't hurt. Or you would do TLS by giving Netty some certificates, and maybe you get one-way TLS, and you kind of bake these things in when you build the application, and they expire after a year, and they never get rotated. All of those are sort of bad security practices. So Istio can set up the TLS tunnels for you. mutual TLS, so a verification of both ends, short-lived certificates that are regularly cycled. All of this stuff is totally possible manually, right? You just have to write the code. So Istio's done that for you, and Citadel is the component that mints those certificates and issues them or rotates them. Those are there's another couple of things that are sort of down in the weeds of making the system work. They're probably not that important. I guess the only other thing I'd mention is the sidecar injector. So this isn't really an Istio component. This is leaning on a Kubernetes feature, a mutating webhook admission controller. If anybody's familiar with those, which basically says, again, that the developer experience gets to be better. So as a developer or an operator, I write a Kubernetes YAML file saying this is my deployment and all of my pods have one container in them, which is my application code. You don't mention the sidecar. You don't have to know it's going to be there. And when that YAML document is submitted to the Kubernetes API server, this mutating webhook admission controller modifies that document and says, I'm going to add another container to the containers list in the pod spec, which is the Istio sidecar container. And as I say, that's free and that's transparent, and that's done on a Kubernetes system by Istio hooking this powerful Kubernetes feature.
Pretty cool. Hey, Matt, thank you so much for the overview. I mean, I think, actually, at least for me, I mean, also looking at the architectural diagrams, I suggest people that are listening to this and maybe listening to this again, just open up the architectural diagram because it really makes a lot of sense the way you explain it. I also like a lot, the flexibility that Mixer gives you, and obviously then implementing or enabling a lot of the features I think we all need to think about when in large distributed systems. Everything that around traffic control, as you said earlier, enforcing rate limits and all that stuff. Now, we didn't just introduce or invite you just to give a quick overview of Istio. I think I also want to learn from you, especially with the work you do right now, because I think you help organizations, with Istio and with microservice architectures. Can you maybe give us a little insight in what are people struggling with? What are the problems people face? What should people, be aware of when they go down that road of a service mesh, or in particular with Istio? Why would they also maybe reach out to you again and ask for more from a feedback?
Yeah, it's an interesting question. So briefly, what I do is I'm CTO at a cloud-native consultancy in London called Native Wave. And as you say, what we do is we help organizations that are looking to become cloud-native. So organizations that are looking to take whatever software stack they've got and move it to a public cloud. And the reasons they do that are varied, but they're always looking to get hold of at least one of the advantages of public cloud and cloud native computing, right? That we all know about. The thing is, it's very complicated. There's a lot of it. I mean, if you've seen the sort of CNCF landscape map recently, it's now you can't read the logos on one page. There's so much there. So people have kind of been tuned in for the last few years. They've heard that there are all these massive advantages, and we've just talked about what Istio can do. And I think it's got a bunch of great features that people will benefit from. But organizations, especially organizations that weren't born in the cloud, they struggle to know which of these things they want, and they struggle to know how to get there. And the kind of depth of knowledge that you need to run Istio, or to run Kubernetes, or to run Vault, or any and all of these systems at production sort of scale and reliability is really deep. So I think we see organizations that don't want to go and simply don't have the capacity to go and learn all of this stuff for all of these products and then take a decision about what they should use. So it's okay for me to go to a conference and say you should use Istio, it's great, but that means that you in order to know that it's doing the right thing and not breaking your application, you need the monitoring set up properly, right? If you run Prometheus at scale, it's not that easy. And that, relies on a working Kubernetes cluster, which relies on all this other stuff. So to your point about when people should use it, what problems people have adopting it, it is often seen as the last step in the adoption of all of these sort of cloud native technologies, which can be a long way down the road for a lot of people who are maybe just starting with Docker or just starting with one of the cloud providers. And it can be quite a daunting thing to sort of build up to. So we really go in and sort of help organizations cut through all of the all of the vendor pitches maybe and work out what technology they need. And then we help them design what, the right stack for them would look like. And obviously we can help build it. And actually we have a managed service platform as well. So we can just help host it as well. You can outsource your IT function to us, which is what we see a lot of companies really, really wanting to do. So they get all the benefits of the latest cutting edge cloud native technologies because, we are experts in that. And, not because we're particularly clever, but because these are the kind of conferences and podcasts that we spend our time at. And then the idea is that the developers in the companies can just finally live that dream of focusing on their business logic, right? They write these 1,000 line microservices that don't have to care about where they run or what their network is or whether things are on fire. So yeah, that's kind of what we saw in the market, and that's why we've decided to do what we do. So it's great for me. I get to learn about all this stuff, bring it to the table, build the best platform I can, and hopefully other people get the advantages of this stuff without the pain.
Yeah, and we also, I think we talked about this in Yash at the conference that here within Dynatrace, we just started an open source project called Captain, where we are also using Istio for traffic control. When we do blue-green deployments or any type of deployment strategy, then we are using Istio, and Captain is automatically configuring Istio and creating all the Helm charts and putting it into Git. So there's also a lot of lessons learned when we played around with this latest and greatest technology. And really our hope is to provide a platform that really allows these teams and organizations to really, let's say, benefit from what cloud native promises, which is focus on your code, write your microservice, deploy it, and let the cloud native frameworks that are out there, handle all the tough work, whether it's traffic routing, whether it is the different type of deployment models, whether it's scaling up, scaling down, and things like that. But the way we learned it, and I'm sure you've learned it as well, it's if you go down to the weeds, it's really there's a lot to it, and it's not as easy as it looks like sometimes. But we, at least you, and now we try to make it easier by figuring out what are the best practices and then combining the right tools and providing a good service on top of it or a good framework.
Yeah, I hope so. And everybody has their specialism, right? I'm sure you learned a lot about Istio, a lot more than you claim to know. I'm sure you know loads from writing Captain. Because obviously it has to lean heavily on Istio. Oh, I'm super, super excited about the Captain project. I think it's great. I think it's almost the last missing piece on top of that stack that we've been talking about, right? That actually gives developers an interface where they can do what they want, which is, here are the 3 versions of my software that I care about at the moment. I want an A/B test between this, and I want an automatic rollback if it blows up during the middle of the night, right? So Istio provides all of the primitives for that. But again, you'd be sitting there pushing a lot of configuration documents, even at Istio's level of abstraction, if you wanted to do that. So I'm super excited about Captain bringing that to the table and automating it.
Yeah. Hey, so I know you're tight on time, I believe, because you're actually right now somewhere in Europe and at a conference. But I got a question for you. So when is it maybe not a good idea to think about these things? When is it, or what are the minimum requirements from an architectural perspective from your app to look into something like a service mesh? When is it not smart to walk down that road? Because I think knowing when it's not smart is just as good as knowing when it is smart. Yeah,
it's a tricky one, right? I guess I would say, don't do science projects. Don't over-engineer more than you need to. A number of people have come to me because I talk about this stuff, or to Native Wave, and said, "Oh, we want Kubernetes. Can you help?" And I've said, "Why?" And they said, "Oh, well, because I've heard of it, and it's got all these advantages and all these features." And I say, "Right, how many services you've got?" "Oh, 3. Okay, and what kind of load are you at?" "Oh, you're pre-release." "Okay, so actually, a Docker Compose file would be just fine." Right, and you use 2 EC2 instances, so you've got a backup. It's certainly not perfect. We could all sit here and pick holes in that all day, but it's going to work, and it's going to work at that scale, and it's going to be totally good enough. The opportunity cost of sitting down for 9 months and building a perfect platform is 9 months where you're not writing your application code, where you're not going to market and getting feedback and raising funding and all of that good stuff. So I think don't build, as ever, don't build more than you need. Mm-hmm. the thing about service meshes is they are really useful. I wouldn't necessarily go multi-region in your cloud provider or even go to Kubernetes until it's ready, until you've got time. I wouldn't even necessarily do microservices until you really have a need, and until you actually do have sort of real scale or real development velocity problems. And as I said at the beginning, we are actually quite good at our IDEs and our tools and our frameworks make us quite good at writing fairly large pieces of code. But if you are going to be calling across a network, I really do think you need these kind of features. Now, if you're in one language, you could use an in-process library. There are libraries for Go and for Python and other languages like that. If you're starting from scratch, right? If you're sort of born in the cloud, then I would actually be really tempted to get a managed Kubernetes cluster. It's a folly to run Kubernetes yourself. I don't know why anybody does, but get a managed Kubernetes cluster, install Istio or Linkerd 2 into it. It's really quite simple these days. Turn the chaos on from day one. So turn Chaos Cube on and turn the Istio stuff on from day one. Do software development properly, do continuous delivery from day one under these simulated conditions of chaos, and then everything will be lovely. And I really would go to a service mesh quite early if you're starting from scratch. I just think they're so valuable. The one thing that does put people off is they build on top of this other stack of stuff that you need, which I admit is a problem. I don't have a perfect solution for it other than to say that now, getting a managed Kubernetes cluster on sort of one of the major cloud providers is really a case of a few clicks. So hopefully it's not that hard. As for when not to do it, if you have a big brownfield legacy site, trying to shove one of these things in may cause you a bit of pain. It may not be what you need right now. Istio has a bunch of ways to mitigate that. You can turn it on sort of Kubernetes namespace by Kubernetes namespace. You can extend what's called extend the mesh. So you can have an Istio mesh running in a Kubernetes cluster that also talks to services on sort of VMs. So if you're on VMs and you're doing a lift and shift into containers, you can do a little bit of your workload, put it in a couple of containers, put that in a cluster, have Istio in that cluster, giving the advantage to them, and then have it set up just so that it can still call out to the old legacy VM stuff. So there's ways to migrate incrementally. But yeah, I can't really help but say I think it's a great thing, and I think you should try to get all of its benefits. And hopefully, it is more simple now than people think. Istio is now version 1.1. I know it got a bad reputation maybe, but those were the 0.1 days. It was released very early with a very clear 0.1 label on, and I think it got so much hype, so much coverage. Everybody said, "Oh, it's great, but it is a bit buggy." Well, yes, it said 0.1 on the tin, and people just got carried away and tried to use it in production. Hopefully now you should have a much better time.
Yeah, cool. Well, and then the good news is, if people have questions on whether it's the right time or not, or are seeking for some advice, we will definitely make sure to put all of your information on the podcast proceedings so that they can reach out to you. Because obviously you do have a lot of experience in how to make companies cloud native or cloud native ready. And so we definitely, if it's okay with you, obviously we'll direct them your way.
Yeah, please. I mean, I'm personally always happy to have my opinions challenged and have debates with people and learn new information. So come find me on Twitter. I'm sure you'll put that information up. And yeah, native wave can help at a company level as well.
Yeah, perfect. Brian, is there anything else from your end?
No, I think it might be time to go ahead and some of the good old summarator.
Do it now.
So, folks, what I've learned today, there's obviously a whole lot to Istio. What helped me in the explanation from Matt, which was phenomenal, explain the different pieces of the architecture, is just look at the architectural diagram, see what Envoy is doing as the proxy that sits in front of all of your services, and then the control plane on top, which makes sure to propagate the configuration to the envoys, the mixer that is doing all the telemetry and then is doing real-time configuration changes and traffic changes, and then also Citadel, which is one of the components for secure communication, and I'm sure a lot of other things too. But Matt, I think this was extremely useful for me, and also thanks for answering the questions on when it might not be the right time, because we want to educate people on new technology, but we also want to make sure they understand when it might not be the right time. And if they're still uncertain, then obviously we will direct him to some of the material that you put out there, and also make sure that people know where to find you. I know you are traveling the world for different conferences. We met in Romania. I know you are in Barcelona at KubeCon, and I think there's other things coming up. By the time that this airs, it's going to be July. And I know you enjoy probably a nice quiet summer, but in case we have people that want to reach out to you and disturb your summer, we'll again still send them your way.
Yeah, I think luckily I'll have conference season all came at once this year. I think luckily I'll have safely got back to London before this airs, so nobody can find me. But no, of course, reach out, reach out online instead. But hopefully this kind of, I love talking about this stuff. I find it super interesting, and I'd like to, as much as Native Wave would like to help people, work out whether this stuff is right for them and implement it. I think a lot of it just comes down to education. If you understand these systems, what they're trying to do, and how they work, then you can make an informed decision to yourself as to whether it sounds right for you, now. So which is why I kind of go around talking about this stuff.
Yeah.
Well, yeah, and in terms of people finding you, when Andy said we're going to put where people can contact you, he did mean, your home address, when you're going to be, when you're typically on the tube and all that. So,
yep, come find me on the bank branch of the Northern Line, 8:30 a.m. every day. If you can elbow your way through the crowds, I'm the guy in a Kubernetes t-shirt.
Yeah, exactly. I want to thank you a ton for this, because it really kind of really solidified this all for me, and I do want to mention again, just stress again for anybody who wants to completely wrap their head around this. Do as Andy suggested. Grab the architecture diagram, take the section where Matt talked about all that, and just look at that while he's talking, because it really solidifies it all. And I think it just also goes to speak again. I brought this up on a previous podcast, Andy, about the maturity of all this stuff. Kubernetes flourishing, taking off, and how now there are so many different services around these things. In the earlier days of all this, cloud native experimentations and all, it was all build your own. And you had to find the time to do it all yourself as well. But as you say, Matt, even your organization, there are services now around it. There are a lot of services around so many of these different aspects of it. It's really, really cool to see how mature this has become in so few years. So it's exciting times, I think.
Yeah, and I could talk all day about how Istio can do protocol translation on the wire and transparent database sharding and all of these things. And I think the technology's always been there, and people are just thinking of novel ways to use it. I don't think service meshes were ever designed to be transparent database sharding systems, but actually, if you think about it and you know how it works, you can totally make it do that. So I don't know whether anybody on the Istio team saw that coming 2 years ago, but it's a thing. So I think we're really just getting started with this kind of technology. It's super exciting.
For me, it sounds you're just introducing the next podcast.
Oh, I signed up.
Yeah, I think you are.
We haven't mentioned it in a while, but we used to have a running competition on repeat guests. I think the most we got up to was 3 or 4, I forget. But we
never late to join the challenge.
Yeah.
Well, exactly. Well, there's a bunch more stuff where it came from. So
awesome.
Let's see what people want to hear about. I'd be really interested to see the feedback on this session.
Yeah. Excellent. What are you? I have one, hopefully a quick one. What are you talking about at KubeCon?
At KubeCon, I'm talking about one of the new features in Istio 1.1, which is a way to basically make easy calls between service meshes. So if you've got 2 Kubernetes clusters in different regions, you absolutely want to run 2 copies of Istio, with a separate control plane each. So a service in cluster A needs to be able to talk to a service in cluster B for whatever reason. You always could do that with Istio, but it was super complicated, and I wrote a blog and a config generator and stuff for it back in the day. Istio 1.1 makes a lot of that first class, so I just kind of explained the theory behind that, and then I'll do a demo of two kube clusters, each with an Istio mesh, and then service in cluster A will be able to call, my backend dot cluster B dot global, and it'll work up it'll end up in the right place, routed via an ingress and egress gateway that can whitelist each other's IPs, end-to-end MTLS, all of the good stuff of a service mesh, but across the globe, for actual globally distributed systems.
Really cool. And I think the recordings of KubeCon will be on YouTube, so people can watch you. Probably by the time this airs, they will be able to see you live.
Yeah, they get them up. They get them up really quick.
Live on tape.
Yeah, and maybe if I'll say, well, exactly. If the live demo doesn't work, I'll send you a frantic email and ask you to cut this section.
Yeah. Okay. All right. Well, thank you so much again, and enjoy wherever you are right now. I know it's evening for you.
It is. I want to say I'm in Vilnius, Lithuania. It's my first time here, and it's really nice. So I just wanted to plug Vilnius. Thanks to all the people in bars and restaurants who've been friendly to me. It's a nice place.
Speaking of feedback, we would love to have Matt back on. We can have him back with or without feedback. But if any of our listeners have any feedback or other Istio topics they would like him to explore with us, please let us know. You can tweet us at pure_DT or send an old-fashioned email at pureperformance@dynatrace.com. Matt, thank you so very much. Andy, great to be on with you as always.
Thanks for having me.
Thank you, everybody.